Hello, propositional logic continued. Now, this one is called conditional, and conditional has another name which is like implies or if then, if then. Now, suppose let us assume SB. B implies R, just propositional names. The result of the condition is such that if B is true, then R will have to be true. That means B is happening is insisting on R's happening. Along with this, in case B is false, then R can be true also, false also. So both of them are okay. But the happening, or if B is true, that means if B is happening, R has no options except happening. That means if you look here, you will see that B is true, R is true for the result, but B is true and R is false is not okay for the result. But if B is not true, like B is not happening, R is okay with no also, okay with yes also. Now this one is an interesting example from a situational case. We have taken two characters, Mr. Bose and Rohan. Suppose B indicates Mr. Bose is at home and R indicates Rohan is studying. Now let us see how the story goes. The story is like, if Mr. Bose is at home, then it is implied, that means it is a guarantee that Rohan is studying. Now it might sound a little abstract, but it is one of the fun cases taken. So if Mr. Bose is at home, if this sentence is true, then B is a valid case. Now, therefore, we will say that whenever B is true, that means whenever Mr. Bose is at home, R is expected to be true. That means only when both of them are 1, the result will be true. That means implies result will be true. But in case when Mr. Bose is not at home, that means B is 0. That means Mr. Bose is not at home. Then no one is stopping Rohan from studying. So Rohan may study, may not study. That means R has a freedom to choose anyone, or R is okay with both 0 and 1. This brings us to B implies R. That means whenever B is happening, R has to happen. That means B is 1, means R has to be 1. Only then the result will be true. But if B is not happening, then R may happen, may not happen, and that is not going to cause any false status in the result. It simplifies to either B is not or R is. Well, we come back and we look at the truth table once again. Either B is not happening. If B is not happening, the result can be true. Result will be true. But if B is happening, then R has to happen. Therefore, not B or R is the resulting expression of S. Now, this we will see later once again elaborately. For the time being, we can say when both are not happening, the result will be true. B is not happening, result will be true. But if B is happening, R will have to have a value of 1 for the result to become true. And the next is biconditional. It is also known as equivalence or as if and only if. Or it is also called if with IFF. Now let B be R by complement T. Now I can call this like that. Let B be R biconditional T. The result of biconditional is going to be true when both of them are true or when both of them are false. This is called biconditional, means either both of them are true together or both of them are false together. It cannot be that any one of them is true and the other is false. Hence, the truth table indicates when both are 0, the result is 1. Or when both are 1, the result is 1. Any one of them is 0 and the other is 1 will not be accepted as biconditional. Alright, coming up are more examples of this chapter. Okay.